Hi, let me tell you about another great Manning book. Designing Kafka Systems, Event-Driven Architecture, Logs, Microservices, Real-Time Event Processing, written by Katya Gorshkova.
Architects have several options for managing inter-system communication, with messaging being a key method. Apache Kafka is a popular choice due to its open-source nature, reliable message handling, and ability to process large volumes of messages quickly. Kafka's strong community support makes it a preferred solution for complex system designs across industries, enabling real-time event processing for applications like fraud detection, personalized recommendations, and predictive maintenance. Traditional synchronous communication methods like REST are becoming less effective for modern business needs. Event-driven architecture, EDA, allows systems to respond to events independently, enhancing flexibility and autonomy. Kafka is well suited for implementing EDA, enabling real-time processing and handling high volumes of data efficiently. Kafka's ecosystem includes brokers, producers, consumers, Schema Registry, Kafka Connect, and KSQL DB. Brokers manage message processing and storage, while producers send messages and consumers read them. Kafka's architecture ensures reliable message delivery and high availability through replication and fault-tolerant clusters. Kafka implements the publish-subscribe pattern, allowing producers to send messages without knowing the consumers. This decoupling enhances system flexibility. Kafka ensures reliable delivery by replicating messages across brokers and providing acknowledgments to producers. For consumers, Kafka tracks the offset of each message consumed, allowing them to resume from where they left off in case of a failure. The commit log pattern guarantees that messages are stored in a strict, sequential order, which allows systems to replay events in the same order they were received. This approach supports eventual consistency by ensuring all replicas can apply updates in the correct sequence. In event-driven systems, data becomes the primary contract, requiring careful handling of data contracts and schemas. Kafka's Schema Registry helps manage message structures, ensuring consistency and compatibility across services. Kafka Connect facilitates data integration between systems, allowing for seamless data transfer with minimal configuration. Data transformation can be achieved using frameworks like Kafka Streams and KSQL, enabling event processing based on message content. Architects must consider deployment options, whether on-premise or cloud-based, and address operational aspects like monitoring, security, and maintenance. Kafka's flexibility allows for various deployment strategies, balancing control and convenience. Kafka is not a universal solution and is best suited for specific use cases like reliable message delivery and event-sourced state storage. It excels in event-driven architectures where events are stored and replicated for fault tolerance. Kafka can retain data indefinitely, supporting event sourcing scenarios, but it is not designed to replace traditional databases due to limitations in handling complex queries. A fictional team embarks on a Customer 360 project using Kafka, focusing on defining use cases, data sources, event schemas, and performance considerations. They discuss cluster management, security, integration, and cost estimation, setting the stage for a comprehensive data processing solution.
Get this book at Manning.com.